I'm going to be talking about Domino's. When I think about Domino's, the first thing that comes to mind is going down to my local high street, going to the local store there on a winter's evening, and purchasing a hot, tasty pizza. So one of my favorites is pepperoni passion, and going back to my place, wolfing that pizza down. Or if I'm feeling particularly lazy and it's a stay-in type night, what I'll do is I'll whip on Netflix, order the pizza using my mobile app, and I know within a couple of moments somebody's going to knock on that door, and a friendly driver is going to smile at me and deliver that pizza right into my hands, and I'll be wolfing it down again. Now, when people think about Domino's, that might resonate to you in terms of what the brand represents. But what people often don't realize is that Domino's is also a sophisticated digital technology platform business that works with over 1,200 franchisees to sell more than 114 million pizzas per year. So there's quite a lot of scale, and obviously those systems need to be quite reliable. What is my involvement at Domino's? So I'm the Senior Engineering Manager at Domino's. I have quite a broad remit. I work across a distributed application, both the front end, the back end. I also work with a platform engineering team, and I work with DevOps and SRE. The last 18 months or so at Domino's have been quite an exciting time because we've gone on a significant transformation journey in order to modernize our platform. And I want to talk to you about that today, but this talk is really about how we modernize certain of our technical capabilities, and specifically the SRE capability. Just to set some context around the SRE capability, when I started at Domino's around 2.5 years ago, it had a support function. We had the monolithic app, and it was very much it was subject to the type of vagrancies that I've seen before at some companies I've worked for. Developers were often, or on-call engineers rather, were often called to respond to incidents on parts of the estate that they hadn't really been involved with. So that was quite an awkward situation for them. You're in that P1, P2 situation, you don't really know what the code looks like, and you're having to respond to that incident. This is primarily because we had a general on-call rota, which didn't necessarily assign a developer to a specific technology component on the estate. Now, the replatforming gave us quite a significant opportunity to change that, and I'm going to be talking to that today. But what I'm going to be sharing is some innovation management theory that we use to actually go through that journey. And I'm hoping you find that innovation management theory useful. However, in the first instance, I've got to talk to you about the actual monolith to microservice transformation. So what I'll do is I'll go through that splitting of the microservices off of the monolith just to show you how we approached that. And some of you might be familiar with the approach. We took a strangler pattern approach to do this. So we'll start there. Okay, so a couple of years ago now, the way that people used to purchase pizza from Domino's was to use this approach. We've got this IIS monolith application. It's a .NET application. It's backed by SQL Server. And what users used to do was to spin up a web browser. This would be a multi-page application. They would connect to this monolith. There would be server-side rendering happening on the monolith, and they would purchase pizza this way. So very simple, very straightforward three-tier architecture, which was common at the time. The first thing we decided to do to modernize this was to decouple the front end from the monolith. And this involved putting in place an API facade layer, which essentially will present utilities within the monolith as if they are microservices. This gave us the ability to put in place a backend for front-end component. And this backend for front-end component comprises of a Node.js application, which is the API piece, which also serves a Vue.js application down to the browser. Now, that Vue.js application gives us a whole bunch of reactivity in the front end. So you've got all the JavaScript reactivity that comes with that technology, allowing us to take a JSON payload straight from the Node.js APIs and just fry that in to the document object model down in the browser. So immediately we had a single page application which was really reactive and fast. And the node APIs connect through to the API facade layer. So what you end up with is a configuration like this. The Vue.js application talking through to the node APIs, which are connecting to the API facade. And this was a good starting point for us in terms of decoupling. We also were able to use an Amplian CMS to start sending assets directly into Vue.js with a starting point. Now, this is where Phoenix starts. Phoenix is about taking the monolith and breaking it down into microservices. So in the first instance, what we needed to do was to put in place a Kubernetes cluster to actually host these microservices. And we needed to front it with an API gateway. We did some vendor selection, had a look at a couple of API gateways. The one that we settled on was the Glue Edge and the Glue Mesh. These are products from Solo, a company called Solo. They are essentially configuration fronts to the Envoy proxy. And I'm going to big up Solo a bit here because it's been a pleasure working with them. I found that the developer documentation around these products is excellent, and the support that we've got from the company in terms of how to transfer in this technology and work with these configurations has been great. The customer account manager has been good as well. Now, the reason why this is useful to us is that it allows us to roll in the configurations using Kubernetes custom resource definitions. And it is easier to work with these configurations than the raw Envoy configurations. So there's a layer of abstraction there which is useful to us. Now, if you have a look at this layout, the routing that we are now able to apply from the backend for front-end component can either go across into the API facade layer through Akamai, which is able to do layer 7 content routing. So if you could imagine a Node.js API in the front end is talking across to a back-end API, you could have some sort of content switching happening on the URI that then sends the traffic down into the Kubernetes cluster. So that's a key control point. Just sticking with the routing, the other thing we did was to put in an external service connector in the actual cluster, which will then give us the ability to move traffic when it comes into the cluster back out to the API facade. And if you have a look at that, you'll realize that it gives us the ability to either switch traffic across microservices, not shown yet, or go across into the API facade layer via means of configurations that we apply into the API gateway. So in terms of microservices that we would then create and break away from this monolith, we took a domain-driven development approach. And essentially what that means is that we have a look at different areas of the monolith and then decide to divide them up into different domains. So the domains that we chose were store, menu, customer, all relevant domains to our website. So to give you an example, there's a store domain. So you can think of this as a Docker container. It has a .NET runtime in it, and that .NET runtime is running a number of endpoints. So I'll give you an example of this. If you go to www.dominos.co.uk, one of the first things you're going to do is put in your postcode to select stores which define a catchment area that can actually deliver pizza to you. Now, that particular endpoint is called store list. And I'll use that example as I move through this. Store list would be running in the store microservice. And what you'd have is traffic coming through the front end. We would apply, as I said, a layer 7 content routing configuration to then cut that traffic into the API gateway. And to now move traffic from the API facade, the monolith, onto store list, we would take this approach. In the first instance, we would put it into a mirror configuration. So what this is saying is that traffic that is entering from the front end to retrieve the list of stores is in fact going through the API gateway, going through the external connector, and going to the API facade layer as the primary legitimate path. And that's what's responding back to the customer. But at the same time, the traffic is also being mirrored onto the store list microservice. And what we have is that .NET runtime is APM instrumented with a New Relic agent. And we're able to have a look at the stability of that endpoint across a couple of different golden signals. So we can have a look at the throughput that's moving through that endpoint. We can have a look at the latency associated with the API, the saturation in the pods, the error rate percentage. And once we're confident that that's looking okay, what we would do is switch it to the second configuration, which is a canary configuration. And the canary configuration starts to move a ratio across the Phoenix microservice, so the microservice itself, and the API facade layer. It uses this external connector to place 90% of the traffic onto the API facade, 10% of the traffic onto the canary, and we watch that for a while. We might watch that for a day or two, just to make sure that those golden signals are looking okay. And then we just start to ramp up that ratio. So we go to a 50-50. We have a look at that. And then finally, we go to 100%, which is now cut store completely, or store list, which is the example endpoint I was talking about, completely off the API facade layer and into that store microservice. Now, in the main, this process is repeated through all of the other domain microservices. And that actually cuts the traffic from the facade into these microservices. Now, what I'm leaving out is the complexity in terms of these microservices talking east-west across this cluster. And that's where most of the challenges in terms of our transformation have actually been. The developers have been looking at using GraphQL, for example, to orchestrate some composite transactions across the east-west. And as I say, we're using the glue mesh, so that would all be the sidecar proxy that's moving traffic across those connections. But just to keep it simple in terms of the cutover, in the main, this is moving things off of the API facade and into the Phoenix microservices. Now, in addition to this, we also have some SaaS external providers that these microservices are connecting into. We make use of a company called Commerce Tools that gives us headless APIs, and they give us certain commerce capabilities, which we exploit via these microservices. And there's also a database within Commerce Tools that we use to operate a data sync from SQL Server, the legacy platform, down into Commerce Tools. And this is really giving us atomic state across those two platforms, giving us the ability to actually split traffic, as I've just described, while we're moving in the canary and actually have data state, which is present in those two locations. Okay, so that's the high-level architecture that we used. It's a strangler pattern. I think some of you might be familiar with that. I'm going to cut the conversation back onto SRE now. Right, so this transformation of the platform gave me a real opportunity to have a look at how we could modernize the SRE capability. I was mentioning that it was very much a support function, and I wanted to modernize it to make it a bit more sophisticated. So the challenge was, how do we actually go about doing this? And enjoying academics, I consulted a couple of journals to just come up with some ideas as to the approach that we could take. And the two academics I had a look at was, the first one is Leonard. So Dorothy Leonard, in her journal, The Wellsprings of Knowledge, she talks about a capability, a generic capability, so any capability, having a couple of different dimensions in it. And she specifically says that there need to be technical skills in that capability. There need to be, technical systems in that capability. There need to be skills that operate on those systems. There need to be managerial systems that make sure that the capability is actually delivering its outcomes, performing as it should. And they also need to be a value set that the individuals that are running the capability have. So it depends what the capability is. I mean, if we just as an example, if you have a look at, for example, if you had a specialized capability to move freight from the US to Australia, the value set would be a sort of a sense of urgency. SRE is different. There's a different value set. But I found this useful because it gives a structure, a general structure to thinking about capability that one can start to work with. The other academic that I had a look at was Thies, and Thies talks about dynamic capabilities. I'll show you those in a moment, but that's, I think, quite powerful innovation management theory. But I'll get onto that in a short while. So what we decided to do was to use this anatomy of capability approach because it gives structure to what a capability might be. And I'll show you how we applied that to SRE in a short while. Now, being Domino's and enjoying pizzas, I've laid out the anatomy in this pizza shape so you can actually see what it looks like. And those are the dimensions I'm going to be working with. There are also icons over there, which I'm going to show you in a moment on a systems thinking or a reconfigurable systems thinking map. And the reason why this reconfigurable systems thinking model is useful is when I talk about capability in the sense, as I'm talking, I'm feeling like it's a bit two-dimensional, right? I definitely get that sense. Although I hope some of you do find it interesting in terms of this view so far. But the systems map is really going to bring things to life. It's actually going to embody what the SRE capability that we've built actually looks like. And I'll get onto that in a short while. Okay, so moving on to dynamic capabilities. So as I was saying, this is innovation theory. It's come about through this academic called Thies. And what Thies is saying is that when you are innovating, a company needs to have 3 high-level meta capabilities that they are operating constantly over time. And what these meta-level capabilities are attempting to do is to keep the organization dynamic. I'll show you what they look like in a moment, in order to get the innovation going and to sustain competitive advantage over time. Now, these capabilities which I'm going to show you, the dynamic capabilities, they in and of themselves are quite challenging to stand up. Right? So there's a significant commitment that one needs to make to actually run these things. I'm trying to run them out of my platform engineering team at Domino's. There's a maturity curve with this, but we're doing okay so far. Right, so when I use this theory, what I do in the first instance is to just lay it out like this. So what I'm saying at the bottom is that we've got a target for renewal, reconfiguration, and recreation. And that target is this SRE capability that we want to now reimagine. Remember, I've said a couple of times, the starting point is just a support capability with engineers being called to parts of the estate that they don't have any exposure to, sort of a rudimentary focus on observability, but that's about it. So what we want to do is make that a bit more sophisticated. How do we go about doing that? Okay, so the first dynamic capability is this capability to sense. And this is really giving adaptive capacity to the organization. And what it's saying is that you should be looking out into the outside world to see what's out there. You might need to have a look out there to decide that you're going to change something because you see a trend out there that's actually going to render your company completely obsolete. Or you might just be looking out there to see what's of interest that you might want to transfer in. And the activities that we would run in this capability are to monitor for trends. I'll use an example of all of the AI material that's out there now. It's quite easy to actually see what's going on in the AI world. You need a lot of time to consume all of the YouTube videos, read the research papers coming out of Microsoft and other areas, or other companies rather. But you've got to monitor those trends. You've got to scan for new technologies. You've got to examine what those competitors are doing. And this is a starting point, right? It's then followed by another dynamic capability, which is called the seize capability. And this is really about giving the organization absorptive capacity. That's saying, okay, you've spotted something in that sense stage. So you might have spotted something like Orca 2, for example, with the large language models that have now, Orca 2 is about using a small language model, which has recently come out in its second version. You might now want to bring that in and run an experiment or a POC on that. So this dynamic capability, it needs to run constantly, but the activities as I've defined it that should be operating from this capability is to learn from the partners. I mean, we've got a partner network now. We work with New Relic, we work with Solo, we work with a crowd that has helped us with Argo in the GitOps space. We work with Commerce Tools. So having a partner network that can help you to actually transfer in the technology. So technology transfer is quite important. Technology transfer in its pure sense is about transferring technology from a university into an organization, but it can also be from private industry. You have to commit resources under uncertainty. So, you know, everybody's busy doing their day jobs in the ordinary sense, and unless you've actually allocated a budget to have a look at running POCs and experiments with the technology that you're transferring in, also under the with a situation that's not necessarily going to give you, within the context that is not necessarily going to give you success, right? So you have to be operating under a certain amount of uncertainty when you bring the stuff in, and that's sometimes quite difficult for people. But you've got to do it in order to innovate, and those are the POCs and experiments that one has to look at. Okay, so this is a value stream that I've been describing. It leads up to the ultimate capability, which is this transform capability. This is the third dynamic capability in the literature. And this is giving the real innovative capacity to the organization. So if you remember, I'm having a look at innovation through this anatomy of capability structural view that I was talking about a short while ago. And this is essentially what it's saying, is that we need to establish new technical systems. So we need to look at putting glue in there. We need to look at the node technology, the view technology. We need to look at putting in Argo for a GitOps model. We need to establish new skills. So the SRE engineers that I'm working with, they are SRE engineers that have joined us from an Indian company, and they have a variety of different levels of skills, and we needed to establish skills with those specific technologies across these individuals. We want to run new routine activities. So you use these skills to actually run activities within the capability. And specifically, I wanted the engineers to focus on reliability engineering, okay, and not so much on observability, because it's very easy to be focusing on observability but not reliability engineering. I'll show you what that means in a short while. The other activities that we have besides that are monitoring setup, service introduction, and support. Those are the primary activities that run within the capability as the core standard operating procedures. We wanted to apply new management systems. So I work with a great, excuse me, I'm just going to have a drink of water here. I work with a great SRE lead that is really managing this capability as a system. And you have to have somebody in there that's actually doing that besides the engineers, because you have to have a look at the outcomes that that system is trying to achieve. We also wanted to establish new values. So the value set that we decided were important for SREs that work within our capabilities, that they need to be aware of what's going on around them. It's not the type of discipline, I think, that you can go deep into a problem and just stay there. You need to know that your colleague has deployed an endpoint upstream that you're now going to consume, and you need to have a look at those golden signals, for example. They need to be bold. So when I get to the reliability engineering practices, a lot of it is predicated on Michael Nygaard's reliability engineering theory around the Release It book. And there are patterns for stability and anti-patterns that work against stability. That's really the material that the engineers need to draw on. And if they see that the endpoint that they are building, the integration points or the caching layers are subject to things such as cascading failures or other problems, what they need to do is they need to boldly stop the line within the development team and say, stop, you haven't put this in. We need to go back to architecture. We need to configure circuit breakers in the Istio mesh or whatever the case might be. They have to be bold. They have to be very technical because it's a developer role, right? So they have to know how to write code. They've got to be familiar with the configurations in Istio, in the Envoy proxy. They need to be familiar with GitOps, running a platform repo to sync in configurations to the custom resource definitions and other areas. They need to be collaborative. Okay, so this is important because the engineers have to work with people around them. And I often find that my SRE engineers are working with a performance test team because the value system is somewhat shared, but they can often talk a different language. And the SRE lead can sort of help connecting that up. The performance engineers are very much focused on sort of getting through a performance run, whereas the SRE engineers want to make sure that the reliability patterns are properly established. And then empathetic. The team has to be empathetic because with the best will in the world, you can put in all these controls, you can have a really sophisticated SRE capability, but sometimes the controls will fail. And then you're into that sort of brass tacks incident management, P1, P2, then you're into problem management and sort of everybody's potentially shouting and screaming and swearing at each other. So you've got to be empathetic in order to run things such as blameless postmortems. Okay, so just to show you where we are at in terms of these different, what I would call horizontal layers of dynamic capability, what we've done is we've transferred in all of this technology. So we've got New Relic that is doing golden signals across our entire estate on those back-end APIs. We've got quite a lot of knowledge around commerce tools, and we work closely with their engineers in terms of the integrations. We've transferred in all the Google SRE knowledge around golden signals, SLOs, error budgets. And my lead is using that material to have a look at how the endpoints are actually performing to take the correct actions to steer the teams in the right direction. Maybe certain teams need to be focusing more on reliability, other teams can focus more on functional development based on these indicators. We've put in Argo, which is all about moving those resource definitions into production using a GitOps approach. In the C's area, which is where we're currently running experiments, I was mentioning the Michael Nygaard's Release It book. My engineers aren't all familiar with this material. Okay, and what I'd like them to do is specifically to read chapters 4 and 5, just those 2 chapters. They don't have to read the whole book, and become familiar with things such as timeout circuit breakers, balance capacities, cascading failures, chain reactions, all of that material, which is essentially reliability engineering, bread and butter. Now, using that, I'll show you how they're going to use it in a moment, but when they apply those patterns, what we want to do is we want to do chaos engineering. So we are having a look at a couple of different tool sets in that space. I'm having a look at Gremlin in the first instance. And we're also looking at Argo rollouts. So Argo rollouts give us the ability to do a microservice native into Kubernetes deployment using a stable candidate pattern. So it's essentially a canary pattern, but it's close to push button with Argo rollouts. So you don't have to configure it all otherwise in the gateway, which is sometimes quite tricky to consistently do correctly. So it's all about getting that automation in there. In the AI space, what we're looking at is something called New Relic Grok. So this is I think it's some sort of language model that New Relic has either integrated into or secretly stood up themselves that takes all of the observability data that you have forwarded across your APMs and then gives you the ability to prompt into it. So for example, if there was an incident, an engineer could go in and say, there's been an incident, what has happened? And what Grok is claiming to be able to do is say that, one of your golden signals moved out. Instead of responding within 300 milliseconds, it's responding in, say, 10 seconds. And the reason for this is that you had a promotion and a whole bunch of traffic came into it. So that's what they claim it does, and we're going to have a look at that. The other thing is OpenAI. So with OpenAI, I'd like my engineers to be using the OpenAI ChatGPT integration simply to ask questions such as, how do we configure the API gateway? How do we configure Istio in a certain way to get a particular reliability configuration properly applied in Istio? And just see the quality of information that comes back, right? We'd like to extend that because I think the quality of information, it's going to have certain information in its parameters that give basic configurations based on probably Solo's documentation. But what we'd like to do in the sense area, and we're just becoming aware of this technology now, and I'd like to take it to C's to actually start bringing it in to run experiments. So we'd like to have a look at this retrieval augmented generation AI concept, and specifically to use this technology called LangChain. So what LangChain claims to do, I'm sure it does it, but we still need to do it, is to, it's saying that what you can do is take some documents, chop them up, put them in a vector database. So what I'd like to do is take our low-level design documents that describe our entire microservices state, chop those up, put it in the vector database, get LangChain to connect into that and also connect to OpenAI, and then ask ChatGPT to first check those low-level design documents and anchor its responses in our knowledge store, right? Then what we could potentially do is start asking it sophisticated questions around how should we be designing our applications, because it knows a bit about precisely what those circuits look like. And then finally, as I've mentioned, this Orchid 2, we want to become familiar with these small language models and to see whether we can try and tune them. Hopefully they don't have a horrible cost associated with them, such as the large language models, where you have to have these big server farms with GPUs, but these ones are smaller and also get some experience with actually that tuning process that one goes through with LLMs. Okay, covered quite a lot of material there, but I'll move through the actual embodying of our capability now. So I'm going to show you what our SRE capability looks like. So in the first instance, you've got somebody up there that's reflecting on this entire system. This is going to be a systems view. It's a model which myself and my lead use to think about how things should be working. So what we have in the first instance are the Phoenix teams. These are the individuals that are building the microservices. And it's fluctuated between about 8 teams and 10 teams over the 18 months that we've been working on it. It has devs, softwares in test, and SREs. The SRE is embedded within the team. The pattern is repeated through all 8 teams. Now, the icons, if you remember the actual pizza I showed you quite a while ago, the icons are representative of the capability dimensions, right? So it's just a way of thinking of those dimensions. You've got the skills which the engineers have. The guy that's going like this is the value set I was talking about. And you've got a management layer over there, which is, think of it in an abstract way. I mean, that's a Scrum Master over there. The SREs are having a look at reliability engineering stories, which I'll show you in a moment. But they are also working with an SRE manager in this bottom stand-up. So what this SRE manager is doing is running a daily stand-up, and he's really looking at what's happening across that group at scale, right? Just to get a general sense of what's happening across the program. The tickets in ADO would have a tag on it, allowing this guy to actually see what's happening across those teams with his SRE engineers. But that SRE manager is supposed to be monitoring and controlling specific capability activities that are happening, very specific capabilities, which I'm going to show you in a moment. But first, just to lay it out, the developers themselves are developing code related to the endpoints. They are moving it down a pipeline using a GitOps model, so through a couple of environments in AKS. Now, what is that SRE manager doing? He is monitoring and controlling SRE activities. These are routine activities that I was talking about. What are those activities? The primary activity is reliability engineering. Okay, and this is what was lacking, and this is what we've now put in to improve things. So in the first instance, what the engineer is supposed to do, I won't click through to this because I'm just aware of time, but the engineer is supposed to have a look at a architecture LLD document. And essentially what that is a typical low-level design document, which has the interfaces of the endpoint, the payload that comes back, but it also has a component diagram that shows the integration of the circuit. And what they do then is they do a component failure impact analysis on that set of integrations. They are supposed to use the Michael-Nygaard theory to have a look at those components and think about how to make those integrations more reliable. So that's the key improvement there. After they do that analysis, what they would do is to create reliability user stories, which are going to go in a backlog in the specific sprint team that they're working in. And then they start fulfilling those reliability stories. These might be things like tuning a timeout in the STO mesh, putting in a circuit breaker in the STO mesh, or putting in a caching layer, whatever it might be. At some point, they would get to a stage where they are starting to do monitoring setup activities. Now, these monitoring setup activities, they are following the Google SRE body of knowledge. So in the first instance, what they would do is use Terraform to roll out a golden signal dashboard. And I think I will show you that. Just click through to this. Okay, so this is a standardized dashboard for every single API, and it has the golden signals. Golden signals will consist of traffic moving through the API, the error rate percentage, the latency, the saturation, which is CPU and memory. And there are some other things that go in there as well. As a second activity, they will configure service level objectives and create error budgets. These error budgets are used by the SRE manager to actually see whether he's having success in terms of managing the entire operation. Okay, so all the error budgets are laid out like this. You can see on the left-hand side, these are all of our APIs running in that .NET runtime. It's store, and these are all the endpoints estimated for full-time store list that I've been talking about. That's the IE version, because we also run an Hyland endpoint for that. You can see most of them are green, but you can see there's a problem up here. There's this error budget compliance that the manager is having a look at. But those obviously need to be configured by the engineer in the capability. What they will then do is they will create service desk support playbooks for incident management. So this is saying in the event of an incident on this endpoint, what should the service desk do when they receive the alert? And then they will configure baseline deviation alerts within New Relic. These are on the golden signals. At some point, they'll get closer to actually doing a release. And before the release happens, the tech lead is expected to do a code walkthrough with the developers to the SRE. The tech lead does a code walkthrough with the SRE so that they get a general sense of what the code is doing functionally. And the SREs would share that information with their peers in that meeting at the bottom. Sometimes if there's a major feature being put into production, we would also have the SRE engineer work with the service desk lead to do a general KT walkthrough, because often the service desk is the first hit point if things start going wrong for the customer. Right, so that sort of leads us up to a point in the capability where we have a whole bunch of observability that's been configured in New Relic. Right, so the main items are the golden signal dashboards, which I showed you, the error budgets, which I also showed you. The error budgets consist of availability, latency, and error rate, and also these synthetics that we also run at times across user journeys, such as logging in, putting things into your basket, taking it to checkout. So we want to know how available those journeys are and also the duration of those things. The alerts will be going down to the service desk and also the SRE engineers. This takes us to a place where we actually do what's called a de-risked release process. And I was talking about how we do a mirror and a canary in the architectural view. This is another view of it. So in the first instance, the endpoint will go in dormant. Then we would mirror it from Phoenix, which is the legacy platform. We would actually mirror the microservice. Server for Phoenix is what I mean. We would then canary onto Phoenix, which is the microservice, and then we would start to ramp up. And the activity for the SREs is actually to watch the golden signals, particularly at the mirror stage, and also at the canary stage to make sure that everything is looking okay, and then to start ramping that up. So it's a cycle that does that. Now, what we found when we were rolling in these endpoints is that our change management group was slowing us down. I mean, you guys are probably quite familiar with a cab, and if you're lucky with a cab, it's happening twice a week. If you're unlucky, it's happening once a week. And it really slows things down. It was definitely slowing us down. So we wanted to innovate this part of the capability as well. And what we said is, let's apply something called pre-approved change, which is standard change. And that means we can put as many endpoints as we want into production constantly, as long as the error budget remains okay. But if the error budget drops below a certain level on a 28-day period, it's breached. And then the penalty for the team is to start going to the cab. Nobody likes going to cab, right? You have to be subject to all of those awkward questions that happen at a cab. And it's just you'd rather not be there. Sometimes when a cab is necessary, but not for this type of thing when we're doing these sorts of releases and watching these indicators. If the team is in this state, they're obviously not taking their reliability very seriously, right? So it's a prompt for the SRE manager to just really clamp down on what's happening in that initial set of activities, because something's going wrong there. It's not a life sentence. They don't have to go to cab forever. Okay, they only go there until the error budget is green again, and then they're back into their pre-approved changes. And then finally, in terms of a governance meeting, what we have is the SRE manager coming into this weekly engineering meeting, which is a governance meeting where he goes through all of the endpoints in production and has a look at their SLOs and their error budgets. So this gives us sort of an early indicator as to whether any of these development teams are trending in the wrong direction, and some actions can be taken there. Okay, so almost coming to the end now. I'm also showing where we're transferring in some of the C's, dynamic capability transfers. So we want to put Gremlin into a step 5 in that reliability engineering activity that deals with testing all of the configurations that we're putting in to for example, the STO mesh and other locations. As I was saying, we want to transfer in LangChain and connect it to our low-level design documents, and then experiment with asking ChatGPT a couple of questions about our state. We also want to transfer in Argo rollouts, because this is being done manually at the moment, and we want to make that almost foolproof, never break. Argo rollouts is going to give us that stable candidate release pattern. And then finally, we want to have a look at New Relic Grok, particularly when we're in Mirror and Canary, and the SRE engineer discovers that there's something going wrong. Hopefully you can use this prompted approach to ask the language model that backs New Relic's Grok, what on earth is going on here? And we'll see the quality of the feedback that it gives us. Okay, so I want to thank you very much for listening to all of that.